Hello students, how are you? Hope you are doing well. Now we start the chapter of correlation officially. So first of all, we have already understood what correlation is, how we express it, and what are the different graphs that show the correlation, whether it is positive, negative, no correlation, etc. Now we start studying the method of correlations. So first of all, we see what are the uses, because we are giving so much energy to understand this concept. So what is the use of this correlation? The first, it reduce the range of uncertainty. It means in case of forecasting or prediction of data, we use the coefficient of correlation. Second thing that the use of correlation is depict the average of relationship, means how the data is related to each other. So it shows the nature and strength of the relationship. And third is base for other statistical methods. The coefficient of correlation is used in many fields of statistical analysis, and the one that we will study in your course is regression analysis. So while doing regression analysis, we use the coefficient of correlation. Now come to the method. So we have two type of methods here. First is graphical method and second is mathematical or statistical method. So what graphical method is? Graphical method means you have to represent the data in terms of a graph. So here we have two methods which are graphical. One is scattergram diagram, or second is simple graph or Correlogram. So these two methods are, what are these two methods? We will study today only graphical methods. So mathematical method, in which we have three type of coefficient of correlation. First is Pearson's coefficient of correlation, then rank correlation, and third is concurrent deviation, that we will study later. So first we will concentrate on graphical methods. So the first graphical method is a scatter diagram, or you can say scattergram or dotgram. So these are the three words that are used to find the correlation between two coefficients, two data sets, using the diagrams. So what scatter diagram is, in and how we make a scattered diagram for a given set of data. So out of two data set, as I have already given you the basic feel of the concept, that we will have two data sets, two things between which we have to find the relationship, whether they are closely related to each other, whether they are not related, whether they have weak relationship. So this type of things we are going to study. So out of two data set, one we name as X and other name as Y. So on the graph paper, we draw two perpendicular line, taking one as x-axis and other as y-axis. So now what we have to do, we will take one point, one value of x and one value of y, corresponding value we will take, and we plot that point on the graph, right? And similarly all the points will be plotted on this graph. So if when we look at the graph, if they show some kind of trend, they are upward direction, they are going upward, or they are going downward, or they are scattered in a whole diagram, so that will give us the idea of the relationship and strength of the relationship between two data sets. So here you have different type of scatter diagram that can take place. The possible shapes are, like in the first case, you can see the perfect positive correlation. If all the data that you plot on the graph, they set on a straight line that is going upward from 0 0, if it is going upward like this, in this case the line is all the data points are on a straight line, they are going upward. So this is the case of perfect positive correlation. If the data sets are on the straight line, but the line is going down, from here it is going down, So that means it is a perfect relationship. Perfect means lying on a straight line. If all the points are on a straight line, that correlation is perfect. Now perfect can be of two type, positive or negative. If the line is going upward like this, so it is perfect positive. If the line is going downward, so it is perfect negative correlation. Right. Now in the third picture you can see low degree of positive correlation, because the data is not on the in this case data is not on a straight line, they are scattered in the graph, but we can see the trend that they are going upward. Again they are going in this direction, they are going upward. So that means this is a positive relation, but they are scattered, they are not on a straight line, therefore they have low degree of positive correlation. Now in the next fourth picture you can see that data is not on a straight line, that means this is not a perfect correlation case. This is again low degree because points are scattered here. Now this the point are showing a trend of downward, so that means this is a negative correlation but low degree because points are scattered here. And next you can see in the next picture, this one you can see again the points are scattered not on a straight line, but they are close rather than this, in this picture and in this picture. These you compare these two, this one and this one, both are in both the points are going upward. This is also going upward and this is also going upward, but here the points are scattered, here the point are closely connected. So this is positive correlation but also high degree positive correlation because points are clustered together. Similarly in this picture points are going downward, it is the case of negative correlation, but points are closely connected with each other or clustered together, so this is the case of high degree of negative correlation. Here there is no kind of trend here, you can't tell whether the points are going or going upward or going downward, so this is the case of no correlation. Here also the points are neither going upward nor going downward, means they are mixed trend, so this is also the case of no correlation. So in this way we can from the picture we can observe what type of relationship exists between two quantities. Now this is the scatter diagram. Now you have come to know that how we make the scatter diagram and how we check the coefficient of correlation, how we check the relationship whether it is positive or negative. Points going upward positive, point going downward negative, right? Then comes the thing whether they have a high positive or low positive, high negative. High and low means the points are clustered together, high. Low means points are scattered on the graph away from each other, so that is the case of low degree. So now we come to the merits and demerits. So merit means what are the benefits of this method. So first is it is a simple method, just you have to plot the point and observe the trend. Next is it show the nature and strength, both things. Nature means whether positive or negative, strength means it is a high positive, high negative, or it is a low or weak. So it tell us the strength also and also the nature. No mathematical calculation, we don't have calculated anything, we don't add number, subtract, minus, plus, nothing we have done. So just plotting the plan, plotting the graph, we get to know about the correlation. Next is least affected by the presence of extreme value. If we have extreme value, let x has value 1 2 3 and then x has 100 value, so it does not affect the answer because we just have to show the trend. So next is line of best fit, that will study you will study later on to how to find the line of best fit. So these are the merits. Now we do have demerits here. First is limited for two variables. Limited for two variable, limited to two variable it has been written. So limited for two variables means only two variables can be plotted on this graph. We can check the relation between two variables only. For multiple correlation and partial correlation this method is not fit. Next demerit is fail to find degree of correlation. So it does just give us a vague idea, or we just predict that this kind of relationship, this is exact value we cannot find from the graph. Exact value, the degree of the correlation is not possible to find from the graph. And next is not suitable for large data. If you have 10 or 20 values, you can plot the graph. If we have 1000 values, then how can you plot 1000 points? It will take lots of energy and time, so it is not suitable for big data. Now come to the hypothetical scattergram. Hypothetical scattergram give us the value of r. What is r? Small r represent the coefficient of correlation. So from the so now you can see the hypothetical scatter diagrams, which means from the diagram you can tell the value of r. R means coefficient of correlation. Like we know that the value of r lies between 1 to -1. So if it is -1 or 1, that is called perfect correlation. -1 means negative perfect correlation, 1 means positive perfect correlation, and perfect means all the point on the line. Like in these two cases, all the points are lying on a line. This line is going downward, so this is the case of negative perfect correlation, means r is -1. And here points are going upward and lying on this same line, means r is 1. Here in the other picture we can see the point are going down, means it is a negative correlation, but the point are close to each other, that means it is a strong negative. So r can have the value -0.6, or you can say -0.5, lying in between the value from 0 to -1. And here you can see the points are going this way, so it is the case of zero correlation, r is 0. So in the this picture you can see points are scattered, so but going upward means it is a positive correlation, but points are not very near to each other, so it is weak positive correlation. Weak means value of r can be 0.3, 0.2, you can say it is among these values. Now in the last case as well, in this one you can see this is the case where a point I lying on this same line, but this line is neither going upward nor downward, it is a straight line, horizontal line, so it is also the case of zero correlation. Right, now next is how to make the scatter diagram. So you are given this set of, like in this you are given the set of data, this is the values of x, these are the values of y. So what you have to do, you have to draw two lines perpendicular to each other. Now on horizontal line you take x value, and on vertical you take y values. Now the values of x are from least value 3 and maximum value is 6 point something, so we plot the point from 0 to 4, 4, 5, 6, 7. So keeping the equal distance we plot the point. And the value of y, we see the lowest value is 25 and highest is 46, so keeping the distance of 10 point we draw the values of y. So in this way you draw the graph, and this is the first step, drawing two lines. On one axis you take x-axis, and on the other you take the values of y, which is y-axis. Next step is you have to plot the point, as the first point is from where it has come, the point which is given this value, first value of x is 3 and first value y is 25, the point is 325. So you have to plot this point 3 on x-axis, 3 from x-axis will be here, and 25 on y-axis will be like here. So this there will be point at the intersect, so this will be the point which have been shown in the next slide. So it is 3, it is near something, it's not exact, but it is 25 here, so you will have here point here. Now in the next graph you can see we have plotted all the point, so all the pair going back to the previous slide, you can see the point. What are the point? 325 is 1 point. Next point is 4.1 and 25. Similarly, next point here. So in this way, after plotting all the points on the graph, you can see they are showing a upward trend. Upward trend means it is a case of positive correlation and point are near each other, so it is a strongly connected positive case of correlation, right? So in this way scatter diagram work. Next graphical method is Correlogram, or you can name it as graph, simple graph. So how it works, this is actually the visual way to show serial correlation of data that changes over time. Means you are given the two set of data and their change over the time. Like in 2000 the production of rice and wheat we have to consider. Then 2000 and 2001, 2002, like this year was given and the data is given. So you are given the years and data, then this graph can be drawn. So in this way you can see now here these can be of these main three types. First is the perfect positive correlation. Both the graphs are of same type and they are going upward. Now this is the case of perfect negative correlation, means they are going upward but they are not of the same or similar shape, they are of opposite shape. So this is the case of negative correlation. Here both are of same shape but they are away from each other, so it is positive correlation. This is a perfect positive because they have same shape, same distance, exactly same way they are going up. So this is, they are of opposite shape, so that is why this is the case of perfect negative correlation. Now here is one example, the how to make the Correlogram. So you are given the data of demand and supply over 2000, 2001, 2002 and up to 2006, and we are given the demand points and supply points. So what you have to do, you have to plot the year on x-axis and on the y-axis you have to plot the data, both the data, both x and y you have to plot on y-axis, only years on x-axis. So after plotting all the points, like in this case you can see how to plot. Like in 2000 we have demand as 103, so here is 103 point and the supply is 107, so you have to plot the 107 point. Then in the next 2001 you plot both the values, 2002 both the values, then we join the point and we get the curve. So both the curve we can see that high degree of positive correlation because they are of approximately of same shape. This is the shape of both the graphs, so they are of same shape, so they are positive correlation. So this was today's lecture. That means you have to do graphical method, solve the questions of first exercise in which you have to draw scatter diagram and correlogram.